Hi Pradeep, Vakash, good evening. Hi Badara, good morning. Let's start the session. So today we'll be looking into Kubernetes. Okay, so first we will deploy Kubernetes. We will briefly see what Kubernetes is and its architecture. Then we will deploy a Kubernetes cluster, and then we will look into the various objects of Kubernetes in detail. Okay. So we'll be spending next 4 weeks on Kubernetes. Okay, so that will be the plan. So basically, okay, first of all, what is a Kubernetes system? So Kubernetes is actually an orchestration engine, container orchestration engine, uh, just like Docker Swarm, and there are other things like Mesos or all the these container orchestration engines. But Kubernetes is the most widely used container orchestration engine, and this is also most complex and feature rich when it comes to the orchestration engine for containers. This is an open source system, so it was developed by Google, and it was actually used by Google for actually within their data centers for more than 15 years. It was actually it was been within the Google with a different name, okay, but later it evolved into this current form. So basically, this Google gave this out as an open source around a few years before. I think around approximately 4 to 5 years before. And now this Kubernetes is under the control of a Cloud Native Computing Foundation, which is a small group of Linux Foundation. So this Kubernetes, the main aspect of Kubernetes is to automate the deployment, scaling, and the containerizing the applications and its management. So this Kubernetes, the word stands for ship captain or helmsman. Okay, so that is what it's denote. So that's why even with respect to its logo, okay, you can see a ship. This what we call it a steering wheel. Okay, something like that. And since it is a Greek word and a little bit difficult to pronounce, okay, many people call it as Kates or K8S, Kates short form. So Kates is the first letter, S is the last letter, and in between there are 8 characters. Okay, so that is why it is called as K8S, Kates. So this internal product, within the Google from which the Kubernetes evolved is called as Brog. Okay, and the Kubernetes services are basically designed to be decoupled and transient. So what does this transient mean? The objects of within the Kubernetes, okay, are expected to be created and deleted at any time. Okay, so we should not keep any critical data within the objects of the Kubernetes, because the pods, that is the lowest or the lowest building block of Kubernetes, can be deleted and recreated anytime. Okay, so any critical data, so the core computing objects of Kubernetes must be treated like transient objects, and if you have any critical data, better you store it in some storages like Ceph. And Kubernetes has an extensive support for storage volumes. So if you see the history of how this Kubernetes evolved, okay, so this is how it is. Originally, this is the Borg, from system from where all the other products evolved. Okay, whether it is Mesos or whether it is Kubernetes or Cloud Foundry, they all evolved from Borg. Similarly, it is the Google which contributed C groups to Linux, and the C groups is the one that made Docker and LXC and Rocket, OCA, everything possible. Okay. So if you see Kubernetes or Google is the foundation for this cloud native industry, especially containers and container based systems and technologies. Okay, without Google, these things won't be there. So what is the architecture of Kubernetes? Okay, so how the Kubernetes is set up? So if you just look into the Kubernetes architecture, so let us say Kubernetes will have a Kubernetes master. There can be one master or more than one master. It is like the master is more like OpenStack controllers. If you are aware of OpenStack, it is more like a OpenStack controllers. Or okay, since you are all aware of Docker, in Docker Swarm we have like master nodes, right? Similarly, here we have Kubernetes master nodes. And in Swarm we have worker nodes, right? Similarly, here also we have worker nodes, which they call it as Kubernetes worker nodes or minions. Okay, so this is how they used to call it. And next, within the master, it has a core component of this master is Kube API server. This Kube API server is the one that receives the requests from the clients and other external systems which wants to create resources on this Kubernetes platform. And after it receives the request, it stores the details into a database. Okay, so because like any system for that matter, which manages the infrastructure, it must need a database to store the state data and resource data, right? So here the database that is used for this purpose is called as etcd. Etcd is a key value store. Okay, and this is what is used for storing the infrastructure information into to persist the infrastructure information. And then suppose say if there is a request to create a resource, okay, this Kube server, after it stores its details into the etcd database, it needs to decide in which worker node it has to create the resources. So to decide that, it has something called as Kube scheduler. So this Kube scheduler is actually it has some set of algorithms which actually decides where the resources, the container resources, has to be scheduled and created. Yes, Pradeep, you have any question?
etcd is somewhat like you can say equivalent to MariaDB of OpenStack.
You can roughly say, okay, both are databases, but MariaDB is an RDBMS database. This one is a key value store. So the type of database is different, but both are databases.
And purpose is same. Storing the database.
Almost, yes, yes. So the scheduler, has some set of scheduling algorithms it runs to decide in which node it has to create the resources. And then actually like the resources are controlled by controller objects. We have something called as replication controller and daemon sets, stateful sets, and deployments and replica sets. Like that, various controller objects are there. These controller objects are managed by the Kube controller manager. These controller objects are the one that takes care of auto healing and replica management and upgrades and rollbacks. Okay, so rollouts, rollbacks, all are managed by these controller objects. And it also has another component which was previously part of controller manager, but now they have split into a separate component called as cloud controller manager, which actually interacts with public clouds or other cloud environments, to take care of the cloud interaction. So that alone they have split as a separate component. In the Kubernetes minion side, okay, so the like it can have n number of systems which actually runs the containers. And this system has one important component called as kubelet. So when actually once the scheduler, this Kube scheduler, okay, so once it decides that okay, it has to schedule the resource on a particular minion node, then it will inform it to this API server, which will be sending the request to the corresponding worker node. That in that worker node, it has a component called as kubelet, which will receive the request and it will interact with the container engine. This container engine can be Docker, which is by default Docker, but it can also be a Rocket or a CRIO, like that. It can be any kind of container engine. And there is also another component within these systems called as kubeproxy, which takes care of all networking aspects of on these minion nodes. So this is the overall architecture of this Kubernetes. Okay, so comparing to, okay, so if you are from OpenStack, comparing to OpenStack, of course, Kubernetes is a very simple system. Okay, so it is not that complex like OpenStack. But comparing to Swarm and other infrastructure managers, Kubernetes is definitely a complex entity. There is one question from Hamid. What is the okay? Sorry. Okay, what is the purpose of kubelet? The purpose of kubelet. So this kubelet is an agent of Kubernetes master on the worker nodes. So this API server sends the request. Suppose if you want to create a pod, the request will be sent to this kubelet on the respective worker node. Kubelet will in turn discuss with Docker to create the necessary resources. So it is like a mediator between the API server and the Docker. Is it okay?
So Rajan, this Kubernetes minions. So that is one server and Kubernetes master is one server if I talk about, and inside one minion server there will be different kubelets and kube proxy. Or one host will have one kubelet and one kube proxy instead.
See here that blue color box. Okay, it is just a logical entity. Okay, each one is a separate system. So the Kubernetes minion is actually a group of servers. Okay, and each server will have a kubelet and a kube proxy. Is it clear?
So this is same thing you are calling workers. I mean minions workers same thing.
Both are same. Both are same.
Okay, so basically that will be one server host that will have kubelet and kube proxy two elements basically, right?
Yes. Yes.
And if you talk about master, that means like somewhat like our OpenStack controller.
Yes.
So this will have many etcd etcd database. API server might be the main server where request will be coming for creating this thing, and then kube controller and cloud member. Okay. So I'm just able to explain the flow. I mean like from where it will go once the request comes for creating one pod.
So it's actually very simple. So the request comes to the API server from the user. Then from here the request will be stored in the etcd. Then it will contact the scheduler to decide like in which minion node it has to schedule the resource creation. Scheduler will inform the selected node. Then it will also inform the controller about the resources that is about to create. So the controller will take over the resource creation and it will be guiding the API server regarding the resource creation. API server will inform the kubelet about the resources that has to be created. Kubelet will create the resources. Okay, and kube proxy takes care of the networking aspect. Overall, the
why there is I mean kube controller manager is one and kube server is another one. I mean same function can be handled by the kube server itself, right?
Where is kube server? I don't see a kube server here.
Kube API server.
See, this is the architecture. Okay, so when someone designs an architecture, they don't put everything into a single box. They have separate boxes. Each will have their own responsibility. That is a good software architecture.
Okay, right. Generally in OpenStack, what we have seen like whatever is API server, that will be the main centralized controller as well, right? If you take the example of Nova or
every OpenStack service has a API server and then other components like controllers, schedulers, etc. Okay.
So request will come first to this. Just go to that one. Kube API server, then it will request a scheduler where it needs to which host it needs to create that one ports, and after that it will inform back to API server, and then API server will contact controller. That please suggest how to. I mean, what exactly here the controller will be doing in this step?
Controller will be creating the controller objects. Controller objects are the one which issues commands to create the pods.
Configuration files and all that might be coming from the controller, right? What kind of with what configuration that pod need to be created?
Yes.
And this then cloud controller manager, what it will be doing?
It will be taking care of the interaction with cloud, other like cloud systems like OpenStack or Google Cloud or AWS. All those interactions with public clouds are taken care by this cloud manager.
Cloud controller.
So now if we just look a little bit deeper into this Kubernetes components, so we have Kubernetes master and set of Kubernetes minion nodes. We have Kube API server, which is linked to this etcd. Etcd, it actually to interact with etcd, there is a command called as etcd ctl, okay, which is the CLI for this for interacting with etcd. Then we have Kube scheduler and controllers, kubelets, kube proxy, etc. And the API server communicates with kubelet, which interacts with the Docker to create the containers. And when it comes to the networking, okay, we'll be using Calico. Okay, so the Calico uses, this bird is actually a dynamic IP routing daemon, which is used by this Flex. Flex is a component of Calico, which takes care of routing, takes care of routing, state management, and distributing the information across the nodes of the cluster. So it is more like a cluster networking manager. And to interact with the Calico, there is a CLI called as a Calico CTL. Okay, so this is the CLI information. So let's just go ahead and do the deployment. That will give you a better idea of how to do things. So here I have two systems. Okay, so I just have two VMs, Kubernetes 1 and Kubernetes 2. So these two are Ubuntu systems, fresh Ubuntu systems. So I haven't installed Kubernetes on these systems. Okay, so let's log into these machines. One is Kubernetes 1, another one is Kubernetes 2. So these two are fresh machines, and let's go to multi-exec mode. You can check the host name. So kubernetes1.example.com, kubernetes2.example.com, and you can check the IP address. One is 10.0.0.115, another one is 10.0.0.116. These are the IP addresses that we have assigned. First, let's run apt update. Then we will see apt. See, there are some packages to be upgraded. So we will say apt upgrade. So this is equivalent to yum update -y in CentOS.
Ranjan, I joined late. This pod we are referring to the container?
No. Pod is a bigger entity than container. I haven't explained much about pod, so don't worry. First, I wanted to give you an overview of the architecture of Kubernetes, and we can deploy the Kubernetes. Then I will enter into pod and other objects. So you didn't miss anything.
Okay, thank you.
Calico is for cluster networking, right, Rajan?
Yes, just like Flannel and VNet.
And Bird is what? VIRD?
We will. It is actually more like a protocol. We will talk about it later. So once this update is done, we will do a reboot. Then we need to install Docker first on both the machines. Kubernetes itself runs as Docker containers.
Roger.
Yes, Badara.
So when you say you're gonna install Docker first, so Kubernetes run it's how to call it run inside of Docker.
Yes, this like Kubernetes entities are run as containers.
Okay. Yes. Okay. So we would install Docker first in order for us to start doing any deployments or any automation in Docker.
Yes.
Okay. Okay.
So now let's do a reboot. And let's install Docker. So previously we were using get.docker.com script to install Docker, but it is also possible to install Docker using Docker IO package, which comes as part of Kubernetes as part of Ubuntu. This will also install the latest Docker. So apt install docker.io will do the installation. Okay, so once the Docker is done, we can just check Docker version to see the version that is installed. It is 18.09, the latest version. So next we need to do the installation of Kubernetes. So to do the installation of Kubernetes, first we need to set up the repository for the Kubernetes in Ubuntu systems. So to do that, okay, just go to etc apt source list.d and create a file called as kubernetes.list. This is very similar to the repo file in CentOS and RHEL. So here they call it as apt sources. So just create this list file, and here we need to specify the location of the Kubernetes packages. So start with the deb, which stands for Debian packages, http://apt.kubernetes.io. Okay, and then you need to say Kubernetes Genial, which is the version of Ubuntu that we are using. Then main is the directory. So how to interpret it? Just go to this URL. So in this URL, under distributions, you will see Kubernetes Genial. So this Kubernetes Genial is the distribution that we are using. So just search here for that Kubernetes Genial. Oh, there is a spelling mistake. Here it is. Kubernetes Genial. We need to correct the spelling mistake. And inside this Kubernetes Genial, you will see the main folder within which it has all the packages. So this is how we define the repositories in Ubuntu. So once you define the repository, so next you must add the key. It is called as GPG key, which is generally used by all package managers, including Yum, to make sure that the packages are coming from the right sources. So we can just download this GPG key from the Google Cloud location. So packages.cloud.google.com/apt/doc/apt-key.gpg. So just get the GPG and then add it to this apt. You will just get an output called as OK. This is just a way of adding the key. Now we can say apt update. Since we have added a new repository, we need to update the repository cache. So we need to run apt update and just make sure that all packages are up to date. If it is not up to date, if there are some new packages, you can do apt upgrade. Okay. So then we need to install the Kubernetes packages. So the Kubernetes documentation is located here. Or this Kubernetes site is kubernetes.io. And the latest version is 1.14, which has been recently released, but we'll be using 1.13. Okay, we don't want to use the freshly released system. Better to use something stable. That way there is no surprises. Okay, so we'll be using 1.13. 14 has been recently released, few days back. So this is the one that we are going to use. So okay, so there are three components that we'll be installing. One is kubectl, which is the Kubernetes CLI. Another one is kubeadm, which is the CLI for Kubernetes administration, and there is a kubelet. Okay, so this kubelet is the so these three systems, these three packages we need to install. So we can say apt install -y kubeadm. So when we just install kubeadm, it will fetch the latest version. So if you want to specify a specific version, you can say kubeadm equal to 1.13.1-00. This is one version that we are going to install. Then we can say kubelet 1.13.1-00. Then kubectl equal to 1.13.1-00. So let's install these three packages. What is the issue here? kubeadm depends on Kubernetes CNI, but is to be installed. Okay, it says that package is not there. Okay, so let's pray to God and install the latest version. Hope there is no problem. Looks like the Kubernetes CNI version 0.60 is no more available. They have 0.75, which is not compatible with this 1.13.1. So it looks like there is a recent change to the repository. So we will install the latest version and hope there is no problem. So it is installing 1.14. You can see here it is installing 1.14 version, latest one. So next, so once you have once you have installed, okay, you can also check the memory that we are having here in the system. The master node we have assigned 5 GB RAM, and for the worker node we have assigned 1 GB RAM. Okay, and it is also important that the swaps are disabled. Okay, the Kubernetes will not be will not install itself if the swap is enabled. So we need to disable it. So how to disable the swap? The command is swap off -a. This will disable the swap. Now if you do free -h, you will see that the swap is disabled. So once the swap is disabled, okay, this is not permanent. Okay, this will be reset, and swap will be again enabled when you reboot the system. So if you want this to make it as permanent, make the changes in etc fstab file. So here, if you just come down, you will see a swap entry that you remove it or comment it out. That's it. Now the changes are permanent. Okay. So if you want, you can also reboot and check. Okay, it's booted. Now check the swap. You can see it is still not enabled. Okay. So next we need to install the Kubernetes master first. So exit the multi-exec window. So on the Kubernetes 1 machine, which will be our master, just make sure it has minimum 4 GB of RAM. Okay. We have assigned more than 4 GB, but minimum 4 GB is required. So the first thing that we need to do is okay, we are going to use Calico as our networking plugin for the Kubernetes. So for this Calico, we need to get the Calico, like YAML files. So this is the location of the YAML files. So just get this role-based access control YAML file from the Calico website. Similarly, we must also get Calico YAML. So this is another YAML file for the Calico networking, which has the networking configuration. Okay. So now if we just open this Calico YAML file, so there you will see various configurations related to this Calico networking. So it is quite a big file, around 500 lines, and these are all Kubernetes objects. You can see the API version and the kind, the custom resource definition, blah blah blah, a lot of things. We will talk about these in a YAML syntax later in detail. So the main thing that we need to find out is what is the Calico IPv4 default configuration. So here, if you just grep for Calico IPv4 pool CIDR, you'll be able to find out what is the default IP address that is configured. So this is the IP range that will be used for our containers, basically pods. Okay, all our containers will be using this network. Okay, so this is the pod network CIDR. So this you need to be aware of. So next step is we need to initialize the Kubernetes master node. Basically, we need to install Kubernetes on this master node. So just like Swarm init, Docker Swarm init, here we call it as kubeadm init. So the command to install master node is kubeadm init. Then you need to give the Kubernetes version that we want to use. Kubernetes version, we can say 1.14.0. Then we can say pod network CIDR. So like this, give the same thing as it is here. Okay. And then the output you can store it in the kube adm init.out. So in case in the future, if you want to refer to this, you can refer to this. What is happening? Oh, it requires minimum 2 CPUs, but we have only 1 CPU here. That is another problem. Proc CPU info. So we have only 1 CPU, but the master node requires minimum 2 CPUs. So let's power this off and add another CPU to the system. Okay, there you go. Now we have 2 CPUs. So next we can try the init command again. This will take few minutes for the installation to complete. It will be pulling the Kubernetes images, and then it will be setting up the respective containers where the Kubernetes systems will be running. So now this Kubernetes master node has been installed, and we need to set up few things here. You can see here Kubernetes control plane has been initialized successfully, and to start using this cluster you need to run the following as a regular user. So we need to create one non-admin user, and then we need to run these commands to set up the environment. So let's just save this in a notepad. Now, so I already have one user. If you don't have user, you can just create one user using user add command. But I already have one user, Rajan. So here I can run these commands. So the first command is I need to create a .cube directory in the home directory of Rajan user. So if you just see ls-la, you don't see .cube directory. We need to create the .cube directory. Now if you just look into that, you can see a new directory .cube has been created. Just look into the contents, it is empty. So next is we need to copy the admin.config file from the etc Kubernetes into this .cube and rename that file as config. So do it as sudo with sudo so that it can access it can run the command as root. Now if you just check, it has copied the contents. Okay, the permission is denied. We need to change the ownership. So let's change the ownership. Now you can see it has all the details. So here this is the Kubernetes API version, that is version 1, and then it has the cluster details. This is the cluster certificate authority. Then this is the API server location. So this Kube API server will be listening on port number 6443. Okay, this is the location on which it is listening to. Then it has some contexts like the username and the config details and the client certificates, etc. So these are all required for accessing the Kubernetes environment. If we just do sudo netstat -tulnp grep for kube, you can see 6443, which is used by Kube API server. So the Kube API server uses the port 6443, and then similarly we have the Kube scheduler, which uses port number 10251. And the kubelet uses 10250. Okay, so these are all the common ports that are used. Okay, so once it is done, the next thing is you should now deploy a pod network on the cluster. Use the kube apply to do this. Okay, so and then we need to provide the pod network YAML file. Remember, we already downloaded the YAML files from Calico project, so we need to use that to create the pod network. Okay. So they have already given some reference web page. So in case if you want to explore, you can explore from here. So here you can see Calico and many other options are available. Calico is one of the most widely used Kubernetes network provider. So you can just go to Calico, and there you can go through how it is done. So you can like they follow the same approach. See the calico.yaml and that is used to set up the environment. So this quick shortcut gets you to single host Kubernetes with Calico in approximately 15 minutes, blah, blah, blah. So it does this kube init, then they do all these steps, then they install Calico by using this Calico YAML file, which we downloaded. Once it is done, okay, we will have the Calico up and running. We are following the almost similar approach. So we have already downloaded those files. Let's copy those files. So we'll just say sudo copy root star YAML dot. I will just copy to the local YAML. What happened?
And have you uploaded the mob for this one? Q&A?
Not yet. I will be uploading it later.
Okay.
Okay, these are the two files. So I'll just copy these to temp directory so that from there we can easily copy it to our non-root user home directory. So from temp we can say star YAML dot copy. There you go. So here we have these two files. Now we need to just apply these files to create the network. So just say kubectl apply -f calico dot YAML. Before Calico we need to say RB. Let's look into this RBAC KDD file. So this is a cluster role, API version, Calico node metadata, and it has some rules. API groups, namespaces, verbs, get lost, okay. And then it has some set of role bindings, okay. So this is more about the authorization, okay, fine. So let's do kubectl apply -f RBAC KDD dot YAML. This will create two objects, cluster role and cluster role binding. Next, we need to do kubectl apply -f calico.yaml. This will create the pod network. And we can also set up the BOSS completion so that when we do kubectl and then if you press tab, it will give you the objects. Okay, that will make your life easier. So to set up the BOSS completion, just say source kubectl completion BOSS. Okay. And to make it permanent, I can just put this in BOSS RC. So every time you log in, it will be automatically initialized. Now if you do kubectl, if you press tab, you can see it. Previously it was showing, when we pressed tab, it was showing the files in the current directory, but now it shows various options that we can specify, like kubectl create and edit, all those. If you say C, it will just show this create and etc. Then create, what are the other things that we can create, like secret, service account, role binding, blah blah blah, a lot of stuff. So this makes our working very easier. So to see what are all the nodes that we have now, just say kubectl get nodes. So we have only one node. that is Kubernetes 1.example.com, which is in the master, which is having the master role running version 1.14, which is the latest version. If you need more details about this node, you can say kubectl describe nodes Kubernetes 1.example.com. So this will give you all the details regarding this node. Maybe we can pipe it to list to get more details. So this is the name of the server, Kubernetes 1.example.com. This is the role that the server is playing. And these are all the labels. Remember, we were labeling the Swarm nodes. Similarly, here also we can label the nodes. So the various like labels, like the architecture is AMD 64, OS is Linux, and so it has beta and as well as Kubernetes IO and the host name. Then the node role master. So this is in a key value pair. Okay, so it's like a map which has a key value pair. It's like a dictionary. Then it has annotations. So this is also more like a key value pair. Then we have the creation timestamp, which says when this node was created, and this is the tains. So the tains says that like no schedule. When it says no schedule, it means no non-infrastructure workloads will be run on this master node. If we want to run containers on the non-infrastructure containers on this node, we need to remove this taint. Okay, I will show you how to remove this taint. But generally, in production environment, don't remove these taints, because in production environment we don't run any workloads on the master node. Master node's pure purpose is to control the cluster. That's all. It should not run any workload. So here it has various conditions, and actually which checks whether the Kubernetes has sufficient memory and has no disk pressure and it has sufficient PID and the kubelet is ready, and okay, all those things it checks. This is the IP address and the host name of the server, the number of CPUs and ephemeral storage, and how much RAM it has, and how much is available for allocation. Those things it decides. Then this is the mission ID and the system UUID and the boot ID. All these things it gets from the kernel. OS image is Ubuntu 16.04 and architecture, and the Docker version is 18.09.2. Kubelet version and the kube proxy version. This is the pod CADR, and it shows various Kubernetes like namespaces and the containers, the pods basically. So the Calico node, core DNS node, etcd, and API server, these are all running as pods. Pods are internally actually has the Kubernetes, has Docker containers. Okay, proxy and the scheduler, everything are running as pods. And how much CPU, okay, that it is using, and the limits. There are no limits, but they are using this much of CPU. M stands for milli units. Okay, then it has memory, how much memory it is using, and there is any limit. That limit is also shown here, and then this shows the age. Then it shows the allocation, like totally how much CPU it has been allocated. Okay, so it has requested 1 CPU, and there is no hard limit. Then memory, it is using 140 megabytes. Limit is 340 megabytes. Then here you can check various events. So here you can see the Kubernetes 1 machine status is now ready, node ready. It is in node ready state. Okay. So if you want to check the various namespaces that are available, you can just say kubectl get ns. This will show you the namespaces that are available. The kube system is the namespace in which all the infrastructure pods, the Kubernetes related processes will be running within this kube system. So to look into the pods of this namespace, you can just say kubectl -n, provide that namespace, and if you say get pods, it will be showing you the pods that are running. So remember, these are the ones that we saw even here, when we did the describe of the node. So the same thing you can see here also. Okay, so now the master node is ready. So next is we need to like deploy this worker node. So to create the worker node, remember when we were initializing the master node, it was giving one token. You can join any number of worker nodes by running the following on each as root. So the kube ADM join, and here actually we give the IP and port number of the API server. Then we need to provide the token and the discovery token CA certification SHA script or this string. this shined key. So if you forget to save this command, no problem, we can build it easily. Just to kubectl. So sorry, in the master node, just say cube ADM token list. This will show you the token. You can also say kubectl token create if you want to create a new token. Sorry, cube ADM. Now you say kubectl token list. You can see that cube ADM. I'm making a simple mistake. Wait 1 second. Cube ADM token list. There you go. So here we have the tokens. So this is the token that we have just created. Like that, you can create any number of tokens. So this is the token, so which you can use in this place. Okay. So it was using the existing token, but you can also create your own token. That is also fine. See, the default bootstrap token generated during kubeadm init. You can always get the token by just doing this command. Next, to get this SHA signature, okay, you can get it from the certificate. So you need to say OpenSSL. So there is a certificate available in etc Kubernetes PKI public key infrastructure CA certificate. So this is the certificate. So if you just cat it, you can see the certificate here. So from this certificate you can get the public key, and then from that public key you can try to get the SHA digest. So let me show you how to do that. Just say OpenSSL X509 is the certificate type, public key -in etc Kubernetes PKI ca.crt. So this will read and show you both the public key. So it'll get you the public key. So here you can see the public key, and this is the original certificate. So this you just redirect to OpenSSL RSA -pubin out form der. So this will get you a string, a digest. Okay. So okay, it won't be readable. Just pipe it to OpenSSL digest SHA-256 hex. This will get you the string. So we don't require this standard IN equal to and all, so that you can ignore. So you can just say pipe it to sed and remove everything from starting up to a space. Now we will get, so it will be removing everything up to this space, including the space. So only this will be left out. So using this we can set up the command. So now if we just see here, so let's form the command, and you will be able to see that we are able to do it without this string. So we need to say kubeadm join 10.0.0.115:6443. Then we need to provide the token. The token is already, we are having it here, right? Okay, if you don't remember it, you can just say kubeadm token list. So you can use either of the tokens. Suppose if you want to use this, you can use this, or you can also use this. Then you need to say discovery token CA cert hash, and you provide the SHA-256, then give this string. Okay, so this is what is all about. Kubeadm join, see, token alone is different because we get a new token, and this like discovery certificate hash is very similar to this one. Okay, so just run this command to add the worker nodes as part of the cluster. So now let's come here and run this command. Now you can see The node has joined the cluster. Certificate signing request was sent to the API server and the response was received. The kubelet was informed of the new resource connection details, and we can say kubectl get nodes on the control plane, that is on the master node, to see whether this node has joined the cluster. So just say kubectl get nodes, enter. You can see a new node here, Kubernetes 2. It is still not ready. We need to just wait for some more time for this node to be ready.
Right? kubectl and kubeadm. ADM seems to be, I mean, for administrative purpose, and is it something like that?
Yes.
CTL is for some
Yes.
purpose, ADM.
Yes. kubeadm is an admin UA like CLI, and the kubectl is the normal CLI. Okay, now you can see it has become ready. Just give it some time to initialize. Okay, so if you want to add more nodes, you can easily add. So let's try to add another node. So come here, close this. So just clone an existing Ubuntu
And
system.
in the role, it is showing as none for the
Of course,
Kubernetes.
yes. Yes, only the masters will be given the master role. This is a worker node, so it doesn't have any specific role.
Okay, none means worker, is it?
Yes. So let's create the third node. I will just call it as Kubernetes 3. Clone it. Okay, now we have the system. Let's open this. and we will set then a new IP address and do an apt update and upgrade. Call it as 117 as the IP. Set the host name ctl to kubernetes 3.example.com. Set host name. Okay. What else? Swap off -a, free -h. Also go to etcfs tab, disable swap. Then apt update and apt upgrade. It may take a couple of minutes. So now let's do a reboot. Okay, it's all fine now. Okay, so root 123. I need to go, configure the etc hosts on the hypervisor now. I used 17, right? That was the IP 117. Okay. Let's call it as Kubernetes 3. Also update the nodes.txt in my system. So let me shut down all the VMs and do a restart. So only then this DNS will properly get initialized. I'm yet to figure out how to make this KVM to restart its DNS without restarting the hypervisor. Let's wait for a couple of minutes.
Mr. Rajan, is there any particular reason why you are using Ubuntu for this deployment?
One reason why I'm using Ubuntu is generally Ubuntu has latest packages compared to CentOS. CentOS is still using old kernel, right, 3.10. Ubuntu uses 4.x. So I started liking Ubuntu because it has latest versions of packages. That's why. Otherwise, you can use CentOS or any Linux. It doesn't matter. I need to just add this snapshot ready. Open web manager. Okay, here it comes. Also master node deployed. Then let's start all the nodes and we will do the deployment now. It's taking some time to start. Okay. I don't know why it's taking so long to start. It has started, still ping is not working. Some issue. I don't know what is the issue. Let's find it out. Are we able to ping google.com from here? Huh. Some networking issue. See, even ping is not working. Let me try to switch the network. Strange. No communication is happening. What is happening here? What is this? This is a new error. Oh, it is opening on CentOS 7. Let me do one thing. I will shut down all the VMs and I try it again to restart the machine and see whether that fixes. It's very strange. No errors added to networking. Okay, all VMs are shut down. See, still it is not able to communicate. So I think we need to switch to Google Cloud. I don't know what happened. Some strange issue. Let me just do one thing. Still nothing. Let's try to run TCP dump. It's not even generating any packets. My God, what is happening? Now we are getting some requests. Is there any What is the IP table rules? Whew. IP tables minus F, IP tables minus S. Ping 8.8.8. There you go. Some IP table issue. Why this happened? Who added these entries? So let's check now. This is fine. So let's do one thing. Let's do a reboot again and check. Problem was with IP tables. Okay. Now it looks proper. See? It's getting stuck. Stop this. Do a reboot and check. We need to just, once the systems are ready, we need to just fire one command to add the next worker node. That is this join command. Okay, it's restarted. IP tables minus yes. Cool. IP tables minus tnat. Okay. IP tables minus f. IP tables minus yes. How it got so many entries? Oh, these were added by IP tables minus L. Okay, let's try to do google.com. Now it works. Okay, fine. Start the VMs. See, now it is faster. Oh, some IP tables issue. Okay, I need to spend some time to find out what it is. IP tables are always interesting to work with. Okay, next we need to add the worker node, the second worker node. First, let's check whether these nodes are ready. Okay, it's taking some time. Let's wait. So it has just started the etcd. See here the etcd was not started. Now it has started the etcd, and now it has started the API servers. You can just verify it here. It's very easy. Now let's do kubectl get nodes. There you go. So now both the nodes are ready. Now go to the second node. Okay, yeah, we can log into second node and also to the third node. So in the third node, we need to run the join command to add it as part of the cluster. Oh, we need to install those packages. So let's do it. First, we need to install Docker. Then we need to configure the Kubernetes repo and install kubeadm, kubelet, and kubectl, etc. Now configure the repo. And also put the GPG key. And you can do apt update. Once it is done, install the kubeadm, kubectl, and kubelet. Then you can run this join command again. It will work. There you go. Huh. Kubernetes lookup failed. How come? My God, the host name issue. Wait, it has to be Kubernetes, right? It has to be Kubernetes. There is a spelling mistake. See, now it works. I will do one thing. I will just, okay, how to make this happen? Hostname CTL, set hostname Kubernetes 3.example.com. Okay, now do get nodes. Okay, so here, this is the problem. This has to be rectified. So just to do kubeadm. So to reset, we need to say run this command to revert any changes made to this host by kubeadm or kubejoin. So let's do kubeadm reset. Yes. Okay. Now let's do a reboot on this. A simple mistake. Now let's do the join. Now there is no error. Okay. Okay. So let's do this. kubectl get nodes. So here you can see we have 3 nodes. This will be automatically removed, I think, later. So we have all the 3 nodes ready. So let's do a reboot and check whether it gets removed. That's it. So let's start it again and check. etcd is started, cube ABS server and all the services are started. Now kubectl get nodes. There we go. All the nodes are ready. We need to find a way to remove this. kubectl or kubeadm. I found out a way. We need to update the DB for that. Anyway, so here we have our our nodes ready. So we have one master and the 2 nodes. So we have Kubernetes 1 is the master and these 2 are the nodes. So next we need to go ahead and then create the applications. Okay. So next we need to like dive deeper into the Kubernetes objects like pod and namespaces and deployments and all those objects we will explore in depth. So it is going to be a little bit complicated but interesting. Fine. So let's take a break, and once you are back, we will enter into the Kubernetes objects. So let's take a break for 15 minutes. Relax. Are you all back? Okay. So now next we need to dive deeper into the Kubernetes objects and understand how to create them and all. So basically, this Kubernetes workloads is split into two. One is pods, another one is controllers. Okay, the pod is the actually is the basic building block of the Kubernetes. So it looks something like this. If you just go here. Okay, so this is how the pod looks like. So if you just like as I said before, pod is the basic unit or the building block of Kubernetes, and the pod is not a container. Okay, pod contains container. So this red color box. Okay, so we can just treat it like a pod, and the pod actually contains internally some containers and volumes, etc. So actually it has one container called as POS container, which owns the network namespace. And all the other containers that we are creating within the pod will be sharing the same network namespace of the POS. So one pod will have one IP address. Okay, and then okay, it will also have some like volumes. Okay, which will be used by the containers. So this basically, a pod represents a running process in our cluster, and this pod encapsulates an application container. Okay, like it can be one container or more than one container, and then it contains the storage resources and a unique network IP address, etc. are all grouped together as a single instance of an application in the Kubernetes platform. So Docker is the most commonly used container runtime, okay, that is used for the Kubernetes pod, but the pod also supports other container runtimes such as Rocket and CRIO, etc. Okay, so generally the pod runs a single container, okay, but it can also run multiple containers. The recommendation is to run a single container within the pod, okay. But there are some times when we may require to run multiple containers. Maybe the containers may be tightly coupled with each other. For example, suppose there is one container which is providing you the information to the user, and there can be another container which collects the information. Okay, so those two can be put as part of a single pod. So that is one reason why we can have multiple pods as part of multiple containers as part of a single pod. Okay. So how to create a pod? Okay, so what is the command to create a pod? So to create a pod, we need to set up a YAML specification. So there is a Kubernetes API we need to use for building this. So to get to the Kubernetes API, just come here in Google, search for Kubernetes API reference. So there you go. This is the Kubernetes API reference. Just click here. This will take you to the reference document. So you can go to 1.14 since we are using 1.14. So here you can see the various workloads. You can see pod, replica set, replication controller, etc. Now we are focusing on pod. So click on the pod v1 core. So this is the API which shows the API, the version, the kind, and almost all these things. So when you are when you are sending a API request to create a pod, it must have these fields like what is the API version. So API version defines the version schema of this pod specification. Then it will have the kind which will tell whether it is pod or any other object. Like we have service, replication controller, replica set, like that we have many. Then we have metadata, which actually provides more information about this pod. Okay, so if you want more details, you can just right click on this object meta, and there you'll be able to find out the details regarding that metadata. Where is that? Here it is. Object meta. Come down. So here you can see the cluster name and many, like the name, the labels, Name is the name of that respective object. Label is just a map of key value pairs used for organizing and categorizing the objects, etc. Okay. So let's create one simple pod so that you can understand exactly how it works. Then we can build on top of it. So let's come here and we'll try to create a pod. So kubectl, or I will say, okay, to see what are all the objects that we are having. Okay, you can just say kubectl get all. This will show you all the objects that are there in the Kubernetes cluster. So by default, it has only one service, that is the Kubernetes service, and nothing else. Okay. So to create a pod, okay, we need to create a YAML file. So we'll just create one YAML file, my nginxpod.yaml. Okay. So here you can define API version. This is the first field. So if you just look into the spec here, first it said API version. API version, you can get it from here, v1. Okay, so we can say, actually we don't have to specify the group, just specify like v1 since it is part of the core group. If it is part of some other group, they need to specify the API version also. Or you can specify core/v1, that is also okay. So just v1 is also fine to assume it as core. Then the next is the kind. The kind that has to be used for pod is pod. So specify kind pod. So next we need to specify the this metadata. That is the next field. So here under the metadata, okay. So now we can specify first the name. This is the name of the pod. I can just say my nginx pod. Then we can give the labels. Label is basically a map of key value pairs. So just give app, my web server, something like that we can provide. Then we have the spec, okay, which actually has the pod specification. So this actually designer provides the specification for the desired behavior of the pod. So just open the spec. And here you can see what are all the fields that we can provide for this spec. So like one is the containers. So which actually lists the containers that has to be created as part of the pod. Okay. So if you just open, so this is a container array, and right click and open the container specification. There you go. This is the container specification. So let's put the spec containers. So inside the containers we can, okay, what are the, so it is an array. So array has to start with hyphen. Then what are the things that we can provide? You can just look into all the objects. So the first is the name of the container. Each container in a pod must have a unique name. This will be the DNS label. So just say the name, my nginx web server, something like that. Okay, this is the name, and say name : my nginx web server. And next is the image. You can check the image field here. This is the Docker image name, okay, using which the container will be created. So if this image is not there, it will be pulled. So you can just say nginx. Then next, you can specify the ports to export. You can see the ports here, list of ports to expose from the container. Exposing a port here gives the system additional information about the network connections, say container users, but it's primarily informational. Not specifying a port here does not prevent the port from being exposed. Any port which is listening on the default address inside the container will be accessed from the network. So here you can see the container port array. It is also an array, so it has to start with a hyphen. And you can check the port specification. So it has a name. It is must, okay, so this will be actually unique within the pod. Each named port in the pod must have a unique name. So we can give some name for this port. I can just say nginx port name : okay. So next, don't use tab, use space. So next you can specify the container port. So this is the number of the port to expose. So this is the port number exposed to on the pod's IP address. So we can say container port So for this NGINX listens on port number 80. It is a web server. And then you can also use host port. So the number of port is exposed on the host. Whenever you want to do a port mapping, then you can use the host port. The protocol you don't have to specify. By default, it will be taking TCP. If you are using some other protocol like UDP or HTTP, you can specify. Otherwise, you can leave it. That's it. This is how we create a pod. Okay, so you don't have to remember anything. Okay, everything is there in the spec. You need to just know how to use the spec. That's all. So if you check here, just come to the spec here and go to the pod, and here you can get the the first field is API version. API version is specified here. core/v1 is the API version. Then is the kind, which is nothing but the pod. And then we have the metadata. Metadata, you can just right click and open this. This is the metadata specification. So here you can see the metadata specification. So here there are various fields with metadata specification, but we'll be focusing only on name and labels for now. So name is the name of the pod, and labels you can use it to categorize the pod. And once it is done, then you can go to the spec, which will which actually defines the specification for the pod, like how many containers to create, etc. So the pod spec, if you just right click and open it, you'll be able to see the pod spec, where it has many other like lot of fields are there. But we'll be focusing only on one for now to keep things simple. That is the containers. So this is so you can create n number of containers within the pod. So the container specification, you can look into the container. It is an array. Anything that is an array, you need to start with a hyphen. Then we have the container spec. This is the container spec. And this container spec has many things. So basically you need to specify the image and the name and the ports. For the port, it is an array and there is a spec for it. That is the container port. So that is what it is here. So API version, v1, kind, pod, metadata, name, labels, container, the container name, image, ports, port name, and the port number, all are specified here. So once it is done, then you can create the object. So save this, and to create it, the command is kubectl create or kubectl apply. Okay, both can be used. And you can see my nginx pod.yaml. So this will create the pod. So now you can do kubectl get pods. There you go. It is creating the container. If you want more details, you can just say kubectl describe pod my nginx pod. And here you can see it is pulling the image now. So we can wait for this image to be pulled. Then it will create the container. See, now it has successfully pulled the image, and the container has been created and it has been started. All these events are stored here. Now if you do kubectl get pods, you'll be able to see a pod is running. And let's do a describe on this pod. So here you can see that this is the pod name. It runs, so we didn't specify any namespace. So it by default runs on the default namespace, priority 0, and then the node on which it is running is Kubernetes 3. If you go to the Kubernetes 3 node, and there if you do docker container ls, you'll be able to see the nginx image, sorry, the container. See, and here you can look into, so this is the Kubernetes container. This is the name of the pod, my nginx ws, and sorry, what is this, the name that we gave? Let me just look at the spec. Cat my nginx. Sorry, that is the container name, and the pod name is my nginx pod is the pod name. Default is the namespace. Okay, that is how it is created. So namespace, pod, and the container. And it also has a POS. Okay, so as I said, it has two containers. Another one is a POS container. You can see this is the one that has all the networking details. So you can check here, Kubernetes pod belonging to my nginx pod. So this my nginx. So anytime if you just do docker container ls, and if you try to grep for that pod, what is the pod name? This is the pod name. If you just grep for that pod, you'll be able to see two containers. So the POS container will always be there because this is the one that takes care of the networking namespace, and this is the container that gets attached to it. This is where our application is running. And next is, suppose say if you want to access it, okay, you can try to access it. First, let's do a describe here. Okay, so here for this pod, this is the IP address of this pod. Okay, and it listens on port number 80. So you can just try to do curl http:// oh, what did I do? Describe, copy this IP. Not authorized. Let's try it from here. See, it works. Some networking issue. From Kubernetes 2 machine, we will try. Not authorized, but from here it is actually working. From that respective node, it is working. Now, if we want it to be accessible from outside, then we can do port forwarding. If we just do kubectl if we just do kubectl enter, you can see all the commands. So here you can see the port forward, which forwards one or more local ports of the pod. So if you need more information, just do kubectl port forward --help. So here you can see more details about it. Wait. So forward one or more ports to a pod. This command requires a node to have socat installed and to use resource type names such as deployment method to select the pod, blah blah blah. Okay, so here you can see the pod ports on ports 5000 locally forward. Okay, so let's try to forward this. Kubectl port forward. You can give the pod name. Oh, it's not responding. Wait. Then you can give the port on the host machine and the container port. Okay, so now you can try to access it. So let me try to connect to this server, or we can start a Firefox. 1 second. So now you can say http://10.0.0.115:8181. One 116.117. Oh, it's not working. What is happening here? Okay, it is. Let me check the port IP tables details. IP tables -s -t nat. Script for 8181. It is not there. Okay, it doesn't set the. It is using localhost. Right. Let's just check a few more details. kubectl port forward --help. You can give the address and the pod name. Okay, so listen on port number on all addresses. Okay, so let's do port forward --address 0.0.0. Give pod my nginx pod 8181:80. Okay, now let's try again. See, that was the problem. It was using the local host IP. That was so that's why it was not working. Now if you use this address, it will work. So just make sure you add this address also. So otherwise, by default, it will be using localhost. Okay. So next, Control C. So this is how we can do the port forwarding. Let me just do this port forwarding again and check it here. SNAT, SNAT, netstat minus TULNP 8181. Here you see. See, now it is gone. So actually, whenever you open a port, this master node will be listening on that port, and when the request comes, it will be forwarding appropriately. It is also possible to expose this as a service. Remember, we had the service in Docker Swarm. Similarly, here also we can create services. So there is a separate object for service. So if you just check here, so here if you check, we have something called as service object. So this is the service object. So we need to just create a service, and then it will be taking care of doing the load balancing and all those work. So like there is a command that we can do it without using YAML file. I will show you both. So how to create a service using YAML and how to do it using CLI. So if we just do kubectl get all, now we have only one pod running. Okay, now if you and then this is the Kubernetes service. So suppose if you want to create a service for this pod, you can just say kubectl expose pod, give the pod name, then you need to give the type. So there are three types are there. One is cluster IP, node port, and the load balancer. Okay, so the cluster IP, if you set the service type as cluster IP, then the service will be accessible only within the Kubernetes cluster. If you set it to node port, then it will be doing the port forwarding, and then you'll be able to access it from anywhere. If you use load balancer, it will be employing a load balancer. So node port, then you can give the name for this service, like my nginx service. Just give some name. Now if you do kubectl get all, you'll be able to see, yes, service has been created. And this is so it automatically maps to one port. So this 31482 is the port. Now let's try to access that port. 10.0.0.115 : that port number. Wait, we must be able to access it. Why is it asking for this username and password? Let's come here. This is the service. Let's wait on curl http://localhost this 31482. Surprising. Let's do one thing. kubectl get endpoint. So here we have the endpoint, and this is the service. Okay. So this is the service call. We're able to access it. Why the service is not running? Three one 482. Some issue with the service. Let's try another example. First, okay, we must be able to debug this and find out what is happening. Okay, kubectl get services. So here we have the service, node port is there, it is properly available. And if you do kubectl describe service my nginx service. Here you see this is the label, this is the selector. We do kubectl get pods minus show labels. My god, show labels. So here you can see the label is also matching properly. Node port, TCP, this is fine. So everything is okay. It must work. Interesting. We need to sudo netstat minus tulnp grep 314. Okay, the queue proxy is listening. Everything is fine. So, is there any infrastructure issue? Unauthorized. Level 5 access. I need to check this. What is the problem? 1 second. Let me just do one thing. Maybe there is some issue with this new version. I will do one thing. Let me just do a list snapshots and va notes.txt. Remove this entry. So this might be the issue with the newer version, because we never faced this issue with like Kubernetes 1.3. Okay, I'm already having this 1.3 available. Let me just try with that. Revert. This is Kubernetes 1.3 version. Okay, now let me start this. I will do the same command that we did now. It will actually work perfectly. So this is what I was afraid. Whenever we get a newer version, we don't know what are the new bugs that they are getting introduced into the system. Okay, still it hasn't initialized. We'll wait. Okay, now we have the API server. Now it must work. Still it's not ready. Now we have everything. kubectl get nodes. Give it some time to initialize. How much RAM do we have here? That is the problem. The RAM is very low. Let me increase the RAM on these machines. I will increase the RAM to 5 GB on both the machines. That way both will be faster. Let's wait for the Cube API server and see now the etcd has started, API server has started, scheduler has started, controller manager has started. Okay, now it's ready. Now let's do it again, and this time let's check how it works. Okay, now let's try to create it. So it is getting the image now. It's pulling the image. It has successfully pulled and started the container. Okay. So kubectl get pods, show labels. There you go. If you want to know where it is running, you can also do -o wide. It is running on the second machine, and this is the IP address. So if you do call, here you can see we are able to access it. See, there is like now there is no issue. Now let's just expose it. kubectl. I'll find out what is the issue with this 1.14. It should not be a major problem. Maybe something new that we need to follow. So just do kubectl expose pod, give that pod name, type node port, and name my nginx service. Now the service has been created. Okay, so now we must be able to access it on port number 30635. Let's try to use it now. 30635. See, it works. So some issue with this 1.14 version. I will find out what is the problem later. Okay, so this is how we actually create the services. To see all the objects, you can say kubectl get all. Okay, this will show you the objects, and here you can see the pod that is running, and this service has been created based on this pod. Okay. So next, let's see about more objects. Close this. So we have seen about pod, and then we have seen about the service. Next, I will show you how to create a service using the YAML file. Okay, so let's actually create the same thing that we have done now, but instead of using the expose command, we can do it with the YAML file. So I will delete this service. And check whether the service has been deleted. See, the service has been deleted. We don't have that service now. So to create that service, you need to say my-nginx service.yaml, and here first is you need to specify the API version. So what is the API version of the service? You can check it here in the API document. Service is core v1. So you need to just say v1, and then you need to specify the kind of the service. Okay, so the service kind will be service, so which you can get it from the API document. You don't have to remember anything. Okay, you can just refer to this API document and you can get it. And next is the object metadata. So we can give you a name like my-nginx service, something like that we can provide. Next, you need to specify the spec. So what is the spec of the service? Just open this service spec. And then service spec, here you can see the ports. So this is the list of ports that are exposed by the service. If you need more details, you can just go. So it is an array. So it has to start with a hyphen. So let's specify ports. It is an array. So start with a hyphen. And what are the fields? Just right click and look into the service port. So here the first thing is you need to specify the port that is going to be exposed by the port that will be exposed by the service, and the next is the target port. Basically, this is the name of the port to access on the pod. So this is the pod port, which will be 80. Okay, so this is going to be the port that will be exposed by the service, and this is the pod port. And the port on each node on which the service is exposed when the node type is equal to node port, usually assigned by the system. If specified, this will be automatically allocated to the service. If unused, then it will be, so you can either specify a specific port, or it will be automatically selected. So let's do this. You can just specify the node port. Suppose say 32,000, like that you can specify. Then you can specify the target port. Target port 80. You can give either the name of the port or you can give the port number. And then the protocol is optional. If you don't specify, it will default to TCP, which is perfectly fine for us. And afterwards, there is also something called a selector. If you just come down, you can see the selector. So this selector is used to select the pods to serve this service. So the route service traffic to pods with labels, keys, and values matching this selector. This is very similar to Docker Swarm. So just come here and put the selector. So this is a map of labels. So I can just say app. What was the label that we provided? Just say kubectl get pods show labels. what label we gave? App is equal to WS, right? That is the label that we provided. So we can just give app colon my WS. This is the selector. So all the pods having this label will be selected and they will be provided with the request. Then you can give the type of the service. So here you can see the type. It can be node port, or it can be like cluster IP, or it can be load balancer. So type determines how the service is exposed. Defaults to cluster IP. Valid options are cluster IP, node port, and load balancer. So external name maps to a specific external name, and the cluster IP allocates the cluster internal IP address for load balancing to endpoints. And then it has is none, then the no. So if the cluster IP is none, then the no virtual IP will be allocated for this service, and endpoints are published as a set of endpoints rather than the stable IP. And the node port builds on cluster IP and allocates a port on every node, which routes to the cluster IP. So we will specify the node port so that it can be accessible from external world. So just say node port. Then you can try to create the service. So at the moment we don't have any services. See, we don't have any service. We have only the Kubernetes service running. So if we do kubectl create -f my nginx service YAML. What happened? Oh, okay. We need to specify the port. So the port is also the same node port number, port 32,000. So now, if we do kubectl get service, you'll be able to see our new service, my nginx, and this is the port mapping. So one is the port, and the other one is the node port. So you can, if you just do the describe my nginx service, you can see the details. Like this is the node port, and this is the port, this is the target. So now here, if you just do netstat -tulnp, so here you can see, here it is listening, and here also it will be listening. See, in both the places, the port number 3200 is listening. Let's try to use a different port for node port and different one for the service port. I will delete the service. Now let's go to the VI. Let's give node port as this one and check. Now let's check the service now. kubectl get all. Here we have the service. Let's describe the service. So there you go. Now let's look into how it is getting mapped. Sudo netstat -tulnp grep32. There you go. So this node port is the port that is used for mapping to the port, like on that host, that is the node port. And IP tables does it use IP tables? Let's check. I need to use sudo since here it is. See, okay, here you can see the request from the port 32001. Okay, we need to dive deeper into this IP tables to understand what is the logic. (32,001). So that is the node port. So node ports, when it comes, if it is -TCP and if it is port, then it actually goes here. And what is that mask queue service? Netmask, and then 32,000. So you can see here the service is mapped here to this port. This is the internal service port. So there is a mapping between the node port is the port on which the nodes will be listening, and from there it will be sending the traffic to the service, and service will be redirecting it to the corresponding ports. Now let's try to access that service using the node port. Let's start the Firefox. http://10.0.0.115.32,000.001. See, we are able to access. You can also use any node's IP. Let's use 116. That is the next server. Even that will work. So because when we are publishing a service, it will make sure that the node port is open on all the nodes. If you don't specify any node port, it will automatically select one port. Okay, so let's try. Okay, so if you just try that, delete the service. Okay, go to VI. So remove the node port. Oh, we need to specify the port. Sorry. Okay, now you can say kubectl get services, and you can also do a describe. So here you can see this is the port that we're giving for the service, but the node port is automatically assigned. So this port we didn't assign, so it will just look for the port that is free, and that port will be assigned as the node port, and this is the port that we need to use to access the service. So next, let's look into the replication controller. Okay, so we have been creating a pod, and we have seen how to create a service and also how to create a service using the kubectl expose command. Next, we will look into the replication controller. Okay, replication controller is another object of Kubernetes, which you can see it here. This is the replication controller. Okay. So this takes care of managing the replicas. Okay, so it is a very important service of Kubernetes. And generally, like these days, it is not recommended to use it directly. Instead, we need to use deployment. But still, it is better to know how this works before we go into deployment. So that way you will know that the power of deployment. There is also two things. One is replica set, another one is replication controller. Both we will explore. So first, let's clean up. Okay, now it's all cleaned up. So next, let's see, how we can create the replication controller and what is a replication controller. So basically, the replication controller is so there are various controllers that are available which controls the pod's life cycle, and replication controller is one of the controllers. So this kube controller server is there, right? So that takes care of these kind of controlling objects. So this replication controller ensures that a specific number of pod replicas are running at any given time. If the number of replicas that is running is less than the configured number, it will create new pods. If it is more, it will delete the excess pods. Okay, so that is what this replication controller ensures. So how to create the replication controller? So let's create a replication controller and see how it actually works. So to create the replication controller, we need to check its replication controller API. So let's create the replication controller. I'll just call it as rep controller demo.yaml. So first you need to specify the API version. You can always look into the API version here, that is v1. It is core, so you can avoid it. v1. Then you need to provide the kind is replication controller. Just copy and paste. And next we need to specify the metadata. So here you can see first is API version, then is kind, then is metadata. So just copy the metadata. So this metadata generally, okay, we can give the name for the metadata. I will just call it as rep control demo, or I can just call it as nginx replication controller, something like that. Some name. Then it has a spec. So there is a spec definition for the replication controller. So just open that replication spec. There you go. So here, so the first thing is we need to set the number of replicas. So this is the desired number of replicas that has to be created for the pod. So first we will specify the spec. And first is you specify the replicas. Suppose you want to create 3 replicas, say 3. And the next is the selector. So the selector is a label query over pods that should match the replica count. So how the replication controller decides whether a specific number of replicas or a specific number of pods are running. So that does it based on the selector. Okay, so this is a key value pair. Okay, label key value pair. So you can specify the replicas here, the selector here, and you can specify the selector for the pods. So you can just say app my nginx or something like that. You can give. And next is the template. This is the pod template. Okay, so we already created one pod, right? So that is the same way we need to create the template. So pod template is the object that describes the pod will be created if the sufficient replicas are not detected. So and actually, like for this, okay, when we specify the template, you don't have to specify the API version as the kind. Okay, you need to specify only the metadata and the spec. So let's come here and provide the template. And here you can give the metadata for the pod, where we give the name for the pod, my nginx pod. Then you can also give the labels. So this label has to match with the selector label. Okay, only then the replication controller will be able to stop creating the pods once the 3 pods are created. So just give the same label, my nginx. Whatever label that we have provided here, the same label has to be provided here. So then we need to specify the containers. Wait, after the we need to say spec and containers. So it is an array. Give the name, my nginx container 1. Then you can give the image, my nginx. Then you can specify the ports. Container port, you can say 80. That's it. So it's very simple. So it has 4 sections: API version, v1, kind replication controller, metadata, where we give the name for the replication controller. Then we give the spec of the replication controller, which actually follows this standard. You can see the replication controller spec. And where first is we need to give the replicas. So we have given the replicas as 3. That is the number of pods that will be managed by this replication controller. They need to give the selector based on which it will be checking whether the desired number of pods are running. Then, so that is the spec here. Then it has to provide the template. So this is the template which follows the pod spec. So this is the pod spec which has the metadata and this pod specification. So here I have given the metadata and this pod specification. We can just look into here. So which is the spec section, spec, and inside we need to give the containers and other details. So here if we just come to the pod spec. Okay, so in the pod spec you can look into the containers. So that is the field that we have defined it here, and the container is an array, and there is a separate specification for the containers. So just go to the container spec. and there you can see the image name and the name of the container and also ports. Okay, so list of ports that we want to expose. If you and this is an array, so you need to start with a hyphen. And for the container spec, you can go to the containers port spec, and there you can find out the information about what are the fields that we need to put. Like we have put only container port, but we can also give the name and the host port and all the other things. So now you can just save this, and let's create the replication controller. So for now we don't have anything, we have only the Kubernetes service running. So to create it, you can just say kubectl create replication controller. So you can use create or you can use apply, both are one and the same. The only difference is if you use create the second time, and if the object is already running, it will say that okay, the object is already running, it will throw an error. But in case of apply, you can run it like any like number of times, it will not throw any error. That is the only difference. So apply, what is the problem here? Replication minus is invalid, labels invalid value, yeah, Unix selector does not match with the labels. Let's check. Template method invalid value, string my JNX selector does not match the labels. Let's check the content what I have given. Okay, the image name has to be nginx. This is one issue. And okay, there is a mistake. Spelling mistake was there. My nginx, right? That n I missed. That's the issue. Let's try it again. See, now it got created. Now if you do kubectl get all, you'll be able to see a replication controller with 3 desired pods, but 0 already because it is creating the pods. You can see it has created 3 pods. Look at the pod name. This is the name of the replication controller, and one random 5-digit number has been generated. Okay, so now if you just try it again, you can see 3 pods are running. And if you just do kubectl describe replication controller, kubectl get all, get that replication controller name, kubectl describe, give that replication controller. Here you can see the name replication controller, the selector, the label, and the replicas that they are running. Okay, all the 3 pods are in running state, and all the 3 pods are created. It's all proper. Okay, so this is how we create the replication controllers. Okay, now let's do one thing.
Rajan,
Yes.
these replicas are created on the same machine?
No. So if you just
yeah.
kubectl get pods -o wide, you can see here some are in Kubernetes 1, some are in Kubernetes 2. So it will be spread across the cluster.
Okay, like we have just created 3 like a random number, otherwise 2 will be enough, because if we have 2 on same server, there will be no use.
No. It is of use only, right? Because like see, it is like multiple processes are there. Okay, so it will improve the performance. So okay, there is no rule like we must have only one pod running on one like node. We can have multiple pods running on the same node. It is just load balancing, right? Say for example, okay, so when we are having Apache web server, we don't run only one process. Okay, it will be like replicating multiple processes to make use of this multi-threading or multi-processing. Okay, so we don't say that actually in case of multi-threading, do we run only one thread per node? No, right? The same node we run multiple threads executing the same program. So it will improve the performance. So it's okay to run multiple pods on the same machine. Is it clear, Hamid?
Oh, okay.
Okay. So now let's do one thing. Okay, I will come here and go to this kind of a terminal, horizontal split, which is better. SSH Kubernetes 1. I will do watch. -n.5 kubectl get pods. Okay, so now in the other node, we will try to delete one pod and see what happens. kubectl delete pod. I will delete this pod. Okay, this HD446. Once you delete, immediately the replication controller will sense that one pod is down. It will replace it with a new pod. Let's do it. I'm going to press enter. See, once I terminated, immediately a new pod creation was initiated. This is the power of replication controller. So this is a self-healing approach. So whenever one pod goes down, immediately it creates a new pod in that place. So that way it always makes sure that a new pod is is actually created, and the number of pods is always kept as 3. Even if you try to create a new pod, it will not work. Okay, let's do one thing. We have this my nginx pod YAML file is there, right? So let's go there. And what was the? Let me just come here. Show labels. What was the label? Yeah, this is the label that is very important. So let's use the same label. I'm going to create another pod with the same label as that is used by the replication controller's selector. It is my nginx. Okay, now let me try to create this pod and see what happens. So kubectl create -f my nginx pod. So when we try to create it, it will find out that the number of pods that is matching the labels is 4, so it will immediately delete the excess pod. See? It got terminated. As soon as it got created, immediately it got terminated. Because the controller will not allow us to run more than 3 pods matching that selector, because that is the specification that we are given to the controller. Okay? So now suppose say if we want to increase the number of replicas from 3 to say 4 or 5, you can say kubectl scale replicas equal to 4 -f replication control controller demo. So now you can see it has started creating the new controller. Sorry, like new pod. Now there are 4 pods. Let's increase it to 6. This will automatically create the number of replicas to 6. Now let's reduce it to 1. It will remove 5 pods. It will keep only 1 pod running. Generally, the oldest pod is kept. The younger pods are the ones that will be terminated. That is the logic that it follows. Now let's put it back to 6 replicas. See, it automatically creates the 5 containers. So the 5 pods will be created to match the count. Okay. So when you delete the replication controller, it will also delete the pods. kubectl delete replication controller. Get all kubectl delete replication controller. When we delete, it will also terminate the pods. See. So what if we want to delete the replication controller, but we don't want to disturb the pods? Okay, see here, whenever we delete the replication controller, it also deletes the pods. Suppose say if we want to create the replication, okay, we want to delete the replication controller, but we want to keep all the pods running undisturbed. How to do that? So first let's create the replication controller again. So it got created and it is resulting in creating the pods. Now, when you have want to delete this replication controller, okay, and if you don't want the pods to get deleted, you can just say cascade equal to false. So this will only delete the replication controller, it will not delete the pods. Now if you do kubectl get all, you'll be able to see the pods are still running, but the replication controller is not there. Okay, and then later whenever you want to create the replication controller, you can create the replication controller. If you do kubectl, so it will not result in creating new pods because already the 3 pods are running with the respective labels. So just do kubectl get all, you can see the replication controller back up and running. So you can always create the replication controller, which will result in creating the pods, and later if you want to delete only the replication controller, you can use the cascade to remove that cascade is equal to false to remove only the replication controller without affecting the pods. And suppose say you want to move a pod away from the replication controllers like control. Okay, suppose say this pod I want to move away from the scope of the replication controller. So we all know that the replication controller controls the pods based on the labels. So when you change the label, replication controller will think that this pod is down, so it will replace another. It will create a new pod in that actually to match the desired count. Okay, so that is how it actually works. So let's try to do that. Now let me try to delete a label. So you can just say kubectl label pods. Okay, this is the command. Just do -f help, and let's check the output 1 second. So kubectl label, and we need to say the type pod, and you need to provide the type, and we can also give the name. Suppose I want to remove this pod away from the replication controller's domain. Just provide that pod name. Then you can give the key. So the key is app. App is the key, and the value is mynginx. So if you want to remove that, so either you can change the value or you can, remove that label. So if you let's try to change the value. Okay, removed or hello something. What happened? App already has a value. Okay, we need to override. Overwrite. See here, it got changed. The label got changed. Immediately, it started creating a new container, thinking that pod is down because the controller works based on the label. It is also possible to remove the label. How to suppose say I want to remove the label of this pod. I can say kubectl label pod, give that pod name, then you can give the key minus. This will remove that label. Now see, the label is none for this, and immediately it starts creating a new pod because here the label is none, because we have removed the label. To remove the label, just give the key name minus. That will remove that label. So next, let's try to label the pods again. Okay, so you'll just restore the labels properly as it was before for these 2 pods. So I can say kubectl label pods. Let's give the name of the pods. This is one pod, and this is another pod. Then you can give the label as app is equal to mynginx override. Overwrite. There you go. So now you see it automatically started deleting the pods that it created later. The younger-most pods will be deleted, and it will like maintain only 3 pods now. Okay, so whenever you want to move your pod away from the controller's domain, you can just change the label and then you can work on it, and later when you want to bring it back, just change the label. It will be again part of the controller's domain. This is how the replication controller works. Any okay, so do you have any questions on replication controller?
Yeah, Mr. Raj. This replication controller, like we are creating pods to have containers in it. These pods, sorry, this controller is for redundancy or for multiple instances, like to create you to so the users can have multiple instances to interact with.
It is okay. So it is about no, the users will be able to access all the pods. It is not like one is active and others are passive. All are running. It is like an active architecture. Okay, so all are running, and users will be able to access all the pods. And when you build a service on top of it, the service will act as a load balancer, and then you can send the users can send the request to the service. Service will load balance the request to all the 3 pods. Is it clear?
Yeah.
Okay. So just like this replication controller, there is also another like one called as replica set. Okay. So this replica set generally is used as is actually created as part of this deployment. Okay, replication like controllers are deprecated these days. It is not much widely used. It is the replica set that they use. The replica set and replication controller are almost similar in nature. So let's check the replica set API. So if we just come here, you can see the replica set. So and here you can see the replication controller. In many cases, it is recommended to create deployment instead of replication controller. And similarly, you can also check the replica set. So it is in many cases recommended to create the deployment instead of replica set. So this replica set, okay, we can use it to create the. Okay, it also works almost similar to the replication controller. So let's create a replica set and see how it works. And then we will stop, and next week we can explore the other objects. There are many objects out there. We will explore as many objects as possible. So let me just clean the objects. Let it terminate. There you go. So generally we don't create the replica sets. Okay, replica sets are created as part of deployment, but I will show you how to create the replica sets using the replica set spec. So it is very similar to the replication controller. Let me just close everything, close all the other tabs. Okay, so we will use the replication controller YAML file to create the replica set. So here, let's check the replica set. So like actually look at the version. It is apps v1. So we need to say apps/v1. Okay, this is the API version. The kind is replica set. So just provide that replica set. Originally, it was the replication controller which was taking care of the this entire replication, and when they introduced the deployment, okay, they created a new object called as replica set to that was designed specifically to work with the deployment. Okay, but it is also possible to create them separately. And then you can have the name for this, that is the metadata. Here you can see the metadata. Then we have the replica set spec. It's almost similar to the replication controller. So here, let's look into the replica set spec. So here you can see the number of replicas. So that we have already as 3. Then we have the selector. So we have the selector here. Then we have the pod template. So that's it. So only change that we did was the change the kind. The rest are all the same. It will work as it is. Now kubectl get all. Okay, let's create the replica set. So kubectl apply. You can see you can use apply or create. Both are perfectly fine. -f replica set demo. What happened? Replica set validating selector field unknown. Okay, wait 1 second. Let me check. Selector. Okay, wait. Replicas. Selector colon. Okay. nginx. Okay, let's look into the label selector. Label selector, match labels. Okay, the field is different. Okay, match labels. There is some small change. Match labels. So see, that's why it is always better to check the API document. And inside that it has the labels. Match label is a map of key value pairs. Okay, now it should be okay. See, now it got created. Now if you do kubectl get all, you can see there is a replica set and 3 pods are getting created. There you go. They're all running. Cool. So now let's try to create, like delete one, and it will automatically kubectl. Okay. So let's go to multi-exec, or I will view horizontal. Okay, there you go. So here you can just say kubectl delete pod. Let's delete a pod and see whether it is getting replaced with a new pod. See, when we are terminating, immediately it creates a new container, new pod. So it is almost similar to the replication controller. Okay. So next is the deployment. So we have deployment and cron jobs, daemon sets, and other controllers are there. Okay. We will explore these next week. So you try to deploy this Kubernetes and try to practice with this spec. Okay, the spec is very important, and it also provides you the example. If you just click on kubectl example for each spec, it'll give you the template. So everything is inside this API doc. It's a very good API doc. If you know how to use it, then it will make your life easier to work with Kubernetes. So practice with it, and we will meet next week then. Okay, thank you.
Thank you.